All right, folks, here is the second part of our Lab 7. I'm going to share my screen. I'll just share. Okay, make sure you can see everything. All right, so I have the lab manual pulled up. We went through parts 1, 2, and 3 in the previous video. So now here is part 4. So now we're going to develop what's called a suitability analysis. I talked a little bit about this in class. Um, you want to read through these things so that you know what the heck you're working on, okay? So now the office needs to make a decision looking at residential subdivision permits. There's several rules looking at guidelines for new development within Richmond. You have to make the permit decision. So you have to identify the sites that are not allowed to be developed, right, for environmental reasons. So this will be the presence of any wetlands, any steep slopes, any high elevation zones, and south-facing deciduous forests. Yeah, that one was just added for educational purposes, right, because we're doing an analysis. You're going to use multiple raster queries to identify the places in town that meet these criteria. Although we could do this in a single step, you're going to do this in multiple queries to make sure you get the hang of things, okay? Before we start having you do like a multiple query syntax. First, you're going to identify all the south-facing slopes that are covered by deciduous forests. Since there's two conditions to be met here, one for each of the data sets, the deciduous forest itself and then south-facing, right? So that's going to be aspect. You'll use the AND logical operator for this query. Again, if you need to go back and look at some of this, chapter 11 has those great like little charts about ors and ands, especially for rasters. It's that Boolean operation. So before you get started or continue on, we're going to open up and do a new map pane. We're going to call it suitability analysis, and we're going to add these following layer files. So I'm going to go ahead and do that. I'm going to come over here. So we have surface and map. I'm going to go back to insert, new map. I'm going to call this one suitability analysis. Okay. Then it wanted me to add a few files. So I'm going to open up my geodatabase over here on the right. I'm going to go back to the Word document so that I don't screw anything up. Okay. Richmond land cover, Richmond slope and aspect. Okay, I can remember those. So Richmond land cover, Richmond slope, Richmond aspect. You can usually drag and drop things, but as you can see, it's taking a hot second. So you can also do the right click and add to map. Okay. So did Richmond land cover for me? Okay, fine. Add to current map. There's slope and here's aspect. Okay, yes. Someone asked me about this. If the hypercolor thing is way overstimulating, before you start, go up here to view, go to color vision simulator, and you can change this to a gray scale. Then the colors still show up here on the left, but what you're looking at regularly. If you want to look at this and see how it works, you can do that. And then when you're done looking at it, you can click here on the X and it'll take it away. Okay, so again, if you go under view and color vision simulator, this allows you to change your maps to the different types of vision, whether it's green blind, red blind, blue blind, or full blind. full, excuse me, full color blind. This is a great tool to be able to use, and it's newer. So, okay, back to work. All right, Richmond Dam, Hillshade, roads and trails. So Richmond Dam, Richmond Hillshade, and Richmond roads. Okay, so if you don't have some of those layers, it means that you didn't make them. So that means you need to go back to part 1. Oh, and Richmond trails. Richmond trails. All right, so that, yeah, you need to go back and make some of those, especially the aspect and hillshade. There, you can obviously just, I like to add things from my catalog, and that's why I talked about making sure that things are named properly. So if you have stuff called like Richmond aspect 1, aspect 2, or whatever, you're not going to know which one is which. So that's why you have to clean up your catalog. All right, that was that step. So I've just added a bunch of things. I'm going to go over here and save so that GIS does not crash and ruin my workflow. All right, so double check that the raster analysis environment is still set correctly. You can refer back to part 2, steps 5 and 6 on page 3 and 4. So I'm going to go over here. I'm going to go to map. Where was that? Under analysis, I think. Yep. Environments. I'm going to let it load. It has to think for a hot second. So processing extent is still this. The tricky part is if you aren't sure what this is supposed to be, you have two options. You can do the drop down again. However, look, none of these are here. So you're going to have to add this Richmond boundary over here on the right to have it be a part of the drop down. Or you can click on the browse button here. You can go to your databases, do it this way because you want it to be this Richmond boundary 2 kilometer. Okay. It's still set the same as it was before, but just in case, or if it was blank, and this will happen. I can't remember if it's in this lab or the next lab, but it will automatically change because I think you open a whole new map. So that saves you from having to memorize all these crazy numbers. You're going to click OK. So we are good, and we're going to click Save. So we know our environment is good. Now we're going to use a new tool called the raster calculator. It's under spatial analysis tools. Again, I just go to geoprocessing and I type in like whatever the tool's name is because I don't want to have to remember where every freaking tool is. Raster calculator, right? Okay, so there's a couple different ones here. We have image analysis and spatial analysis. So image analysis is using Python. Oh, this one's using Python too. But what are we doing? Are we looking at an image or are we analyzing spatial tools? We're actually analyzing spatial tools. So an image would be something like my drone data that I'm using for the whales. And then we break it down from video into actual images. And so that's when we would use that image analysis setup. Okay. So raster calculator, spatial analysis tool. Go ahead and open it. And again, this should look familiar to you. I'm going to make it a little bigger. You can click on things. You can check the operators over here. And then always make sure you don't forget to name your output raster. So let's see. We want to create a query whose syntax matches what you see in the figure below. Your goal is to select those locations with deciduous forest that face south. Okay. So the code for deciduous forest in the land cover is 41. Oh, good. That's nice. Now I don't have to go hunting around for that. And the aspect derived from the DEM has a continuous numeric scale, so digital elevation model. You want to select all the cells that are within plus or minus 10 degrees of true south, also known as 180 degrees. Finally, you will use the AND logical operator, denoted by the AND symbol, to join the two query components, land cover class and aspect. As a side note, you can double click on the raster name up here and add it to the syntax area. Also pay attention how each of the criteria are wrapped in parentheses, meaning make sure you don't screw up your code. Okay, so scroll down. Do we expect you to do this by heart? No, look, it's right here. Okay, so I want Richmond land cover equals 41 and Richmond aspect equals greater than 170 because that's 10 minus from 180, and Richmond aspect is less than 190. And as you can see, I have single parentheses around land cover because there's only one thing from that particular feature class, and then I have double parentheses around the two different aspects because I want two selections within a feature class. So that's why you put double parentheses on that. Okay. And then you can just call it Richmond step 1. So I'm going to go ahead and do that. So Richmond land cover. I'm going to double click. I'm going to go ahead and put my parentheses in here. I am going to scroll down for the double equal sign so that I don't mess that up. I can type in 41. Then I can scroll down for my and sign. I mean, you can put it in there if you want, but I really like just not leaving things to chance. I'm gonna do a double one. Then I want aspect. Come on, aspect. And we want this to be greater than 170 parentheses, and we want aspect, aspect to be less than 190, right? So that's 10 and 10 and double parentheses. So, right, there's two selections from the same feature. So you have to do the double parentheses in here because you're trying to find something that's in between. And Richmond land cover, just we want that to equal 41 because as we know, that's the code for deciduous forest. So instead of it being called raster C underscore 1, we are going to call it Richmond, what did it say? Richmond step 1. Okay, let's see, Richmond step 1. Cool. It's going in my Lab 7 GeoDatabase. Always double check this just in case. All right, and click run. Oh, it failed. That's nice. What did I do? So great. This is called an error, right? So open up the details. Something unexpected caused the tool to fail. What does that even mean? Something unexpected. Lame. Okay, so make this a little bit bigger. To report a bug, failed to execute. Something unexpected. Okay, error 999. So here I can click on it, and let's see. This is what you should always do with an error. It's taking me to oh, it's a bug. So it's literally not something I did. There's a bug. Does this mean I have to stop doing GIS? No, nice try. I'm gonna go back to my GIS. This is what I do when there's a problem like this. Okay, I close the tool. Yes, I know this is annoying. And I open the tool back up. Make sure you open the right one. And I start over. Yep, I know it's obnoxious, but it is what it is. Richmond land cover is equal to 41 parentheses and and Richmond aspect double parentheses here is equal to, oh no, less than, what is it, less than 190 and greater than 170, right? And I gotta put a little parentheses right here. Land cover, nope, aspect is less, okay, less than 190 and greater than 170. See, I have to talk to myself a lot because I need to talk through what I'm doing. Whatever works for you. Okay, no shade one way. Oops, no, only one there. Okay, so double on the end, single in the middle. Call this Richmond step 1. Richmond step 1. All right, and let's run it, see what happens. Oh, look at that. Oh, come on. Magic. Oh my gosh, magic. It worked. See? Now I'm going to save really quick. Boom. So I don't lose that one. Because now I have Richmond step 1. You can see we have values of 0 and 1. So what that is the values of 0 do not have what we want. The values of 1 have the correct deciduous forest and the correct aspect, which is facing south, right? Is that what we decided? Okay, so cool. This is the binary concept of using a raster calculator to do a query. Okay, cool. I saved it. Now I'm going to keep going. So the output, oh, see, let's talk about this. True values and false values. Render the ones with a bright color and make the zeros invisible or have no color, and then turn off all of the layers except for the Richmond DEM and Richmond step 1. Okay, cool. So let's see, turn off trails, roads, hillshade, leave that one on, aspect, slope, land cover. Okay, cool. And then I gotta go back in here and do symbology, right click, symbology. I'm gonna show you a little trick too. You just double click here and you can double click here and do no color if you need to be fast or something. Okay. Red's pretty bright, but what's the problem with red, right? Yeah, let's fix that. Okay, so um, 0 and 1. Is it because my elevation model? Yeah. See if you turn the elevation model off. So you can see the elevation model is like this. So you probably want to pick a different color because usually elevation is in a graduated something. I'm just going to pick something goofy like hot purple. I don't know. That works for now. All right. I go ahead and click save. Is it perfect? No, but it works for now. Okay. Great. Now you've identified some of the off limits in development at Richmond, but you still need to factor in the rest of the criteria. So basically what we figured out is those hot purple spots are where they cannot, or can they or cannot? What is it? Code, what is it? What does it say? You want to identify sites where there's not steep slopes, high elevation zones and south. Okay, yeah, so these are the ones, the hot purples are where they cannot build, basically. All right, so what you want to do is keep a note to yourself that you're coding to create spaces where they cannot build, okay? So that way you do it the same the whole time. So you want everything to be 1 if you don't want them to build there, because if you mix up your 0s and 1s, or you're okay and not okay, then you're going to be sad, your stuff isn't going to work. Okay, so let's do some more off limits areas. Next, we're going to combine the results of our first query in step 1 with the criteria for wetlands. Lots of land cover 61 or 62. Steep slopes is slope over 40, and high elevation is the elevation model greater than 1500. So we're going to go back to our super fun raster calculator. I would just personally, I would just clear this, delete, open my stuff back up, and let's see. So Richmond land cover has 2 things. So it's going to need how many, right? It's going to need 2 parenthesis thingies. So let's do that one first. Richmond land cover is equal to 60. And then we put a single parenthesis there, single parenthesis here. We have or in here. Additional. Oh, is it in here? Okay, I'm going to type in or. And we have parentheses. Richmond land cover is equal to 61. Okay, and I'm going to do double parentheses there because there's 2 things within 1 feature class, right? What else does it want? It wants 60 or 61 or 62. Oops. So this is supposed to be 61 or 62. There we go. Always double check your stuff. Then we want Richmond slope is greater than 40. Cool. And Richmond slope is equal to, where did it just go? Equal to, sorry, I should have had some more coffee before I started doing this. Oh no, is greater than 40, not equal to 40. Parentheses around Richmond slope. And parentheses, what's our last one? Is it aspect? Oh no, digital elevation is greater than 1500. Okay. Then we do Richmond DEM. Oops. Just have to pay attention to where you put your things and where your cursor is. That's all. Richmond DEM is greater than, come on, greater than 1500. And then go ahead and put parentheses. So this should work, and we'll see if I screwed up any of the code. Okay. Um, let's see. I used to be able to make this code box bigger, but I guess you can't. Okay, so land cover is equal to 62 or 61. Okay, that has double parentheses because it's the same feature class and we're picking multiple things out of it. And Richmond slope is greater than 40 and Richmond dem is greater than 1500. I think we call this step 2. Okay. There are no and operators in this query, only or. So remember the or operator in the raster calculator is represented by the vertical line as a pipe. Oh, okay, so I can't just type in or. So I'm going to go back in here. Good thing I read the manual, right? And there it is right there. Okay, so there's my or, my little fun pipe. So instead of Richmond step 1, I call it Richmond step 2. Any other tricks and stuff written in here? Make sure the query is surrounded by parentheses like you see in the query syntax in number 2 above. Double hint, the land criteria needs to have double parentheses. Yeah, okay, we did that. It's just helping, right? All right, so go back here. It's step 2. Yep, double parentheses around my stuff and run. Dun, 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 dun. Oh, thank goodness I coded it properly. Oops. It's all 0. Is that correct? It should look like this. So no, I screwed something up. Great. All right. Well, what I'm going to do is go back to GIS. I'm going to delete this, remove it here. I'm going to go to my catalog. I'm going to remove step 2 because it's wrong. Delete. Yes, I want to permanently delete that. And I'm going to go back to geoprocessing. So something in here is not quite right. So let's try 61 or 62. You know, sometimes code is weird. Richmond land cover, 61 or 62. Is there space? No, I don't know. And Richmond dem is, it's greater than 1500, right? Yep, greater than 1500, 61 or 62. Steep slopes, greater than 40, high elevations, greater than 1500. All right, let's try it again. So awesome. So something I did is not correct. So what you can do is now, because I've done it twice and I'm annoyed, I'm going to go into my rasters and check. So are there any elevations of 1500? Yes, there are. So it's not that one. Are there land covers? 61 and 62. Yep, there are. Is there a slope greater than 40? There is. So why isn't this working? Okay, so this is what I would do. I'm going to open up the attribute table. There's only zeros, so that definitely means I did something funky. So I'm going to remove it. No, God damn it. Remove it. I'm going to go back to my catalog. I'm going to remove it. Delete. Yes. I'm going to try. Something in my code isn't working properly, so that's part of it. Test the code doing this. I'm going to test to see if Richmond, call it LC2. I'm just going to test to see if the land cover works. Okay, so it wasn't the land cover, because I can do this and then join these together. All right, so now I'm going to add and Sorry, thing, slope. Slope is greater than 1500. Parentheses around it. Okay, I'm going to call this LCS2. You know, I'm just making stuff up because I want to test it and see what's going to run. Oh, that's the problem, is the slope. See, now I figured out that it's the slope because that's what's graying everything out. That's annoying. So there is not a place where the land cover is deciduous and the slope is over 1500. Okay. I just did Richmond slope. Let's see. It's like, this is just a way for you to figure it out, right? I'm going to call this slope 2, Richmond. Slope 2, run. See, something's not right because in Richmond, we know that there are slopes. Oh, oh no. Is that right? Richmond slope is less than 90? Oh. Okay, so this is when you go back. Slope. Yeah, Richmond, there is no Richmond slope over 1500. Is that correct? Yep, doesn't looks like it. We can open up the table for this. That's right. Okay. I'm gonna go back to my catalog. Is that right? Sheet. Where did I get this from? DM, right? Where's my digital elevation model aspect slope? So this is where you go back. How did I get my slope? Where did I get my slope from? Okay, this is how you troubleshoot things. Because you could just raise your hand right now and ask for help. But if you were doing this by yourself, you need to figure out how to do it. Okay, so we did DemChit. So this is basically land cover and digital elevation. How did I figure out my slope? I used a tool up here. Let's see, which tool was it? So Hillshade, surface Hillshade. Okay, I used the digital elevation model. I got that. I had a buffer. I already did that one. Raster processing. Yeah, okay, I clipped it. Cool, whatever. Clipped it. I did land cover using that layer. Hillshade and land cover. Okay, I clipped the roads. Okay, so in my slope tool, I did the input of Richmond DEM and the output of Richmond slope. It's doing this in my other model. So I'm going to go back here. I'm going to go to surface analysis and I'm going to redo this. Okay, so I'm going to go to geoprocessing. I'm going to type in slope. Okay, I'm going to do a spatial analysis tool. Okay, I'm going to input my Richmond EM, which is the digital elevation model, which is basically what I did in the beginning, right? So I'm going to do this part. Okay. My output, I did by degree. Let's see, let's make sure I did this correctly. Your output's going to be Richmond slope number 2, because this is new. Richmond slope 2, its degree. Everything else is supposed to be right. Output measurement is degree. I'm just making it. Okay. And I'm going to run it. Let's see. Okay. So it looks like that slope is still less than 1500. So I wonder if that's just part of it. So, okay, I'm going to get rid of all these extra things that I just made. So Richmond slope 2, go away. We remove. I'm going to go back to suitability analysis. I'm going to get rid of these extra things that I made. I have to figure out how to do this. So I wonder if I took the overall dev chit and I made a slope out of that. Let's see what happens when I do it that way. So I'm going to look for the original digital elevation model here. I'm going to just call it slope. Okay, I'm going to run it, and it's going to do the whole thing, not just Richmond. Okay. Oh, it's clipped. Oh, it's still clipped. Because the other one is clipped, that's why. So yeah, we just don't have anything over 1500. And that. Step one, getting rid of things that I do not need. Okay, this is where it's really important that you don't save things that you're messing around with. Yeah, no, it doesn't like it because those files are gone. Okay, so Richmond step one, we know we did that. I'm gonna save. I'm gonna go back through. Okay, so aspect, with that. Did our land cover. So I'm gonna go back to geoprocessing and I'm going to look up our raster calculator again. Open that spatial analysis tool. And I'm going to go back through and do this. So I think I need to look at Richmond Dem definitely has higher than 1500, so maybe I'll do that one first. Okay, so Richmond Dem is greater than 1500. And oh, see, look, it got mad. That string line. Oh, so there is something wrong with my code. So I messed up my code somewhere. Invalid syntax. What did I do here? Richmond down. Come on, Richmond down. And it is 100. Why doesn't it like that? Line one raster syntax error. Invalid syntax. Create the expression. Yeah, I know. This tool list contains the only tool you can use. Okay, why is this? Okay. Oh, it's because I had some weird line in there for some reason. Okay. So space. Why does it keep doing that? And oh, so something's going on with my raster calculator. I don't know what this thing is, but I'm gonna close my raster calculator. I'm gonna save my whole project. I'm gonna close GIS and open it again. See if whatever that weird thing is goes away. Okay. So can you still see my screen? Just want to make sure. Yeah, okay, cool. So I'm gonna open up GIS again. You know, if you aren't having this problem, obviously you can skip forward to the part of the recording that, where I figured it out and got forward, obviously. But if you do have this problem, this is how I'm figuring it out. Okay, so back, I'm going to open up geoprocessing, type in raster calculator, or look, it's under recent, so just open it. Cool, thank you. I'm going to do Richmond DEM is greater than 100. Okay. Ignore that for right now because I don't know why that's doing that. Okay, stop it. And stop it. And other things because now my brain is all over the place. All right. Okay. Richmond Dem is greater than 1500. Richmond Slope is greater than 40. Okay. Slope is greater than 40. Parentheses around these two. And then what's the last one? Something. Oh, land cover is 61 or 62. And land cover is equal to 61 or 62. So we're going to do double parentheses. Land cover, come on, is equal to 1. We could try doing it this way since it was weird to us last time. Or 62. 62 with cover is double equal to 2. Try. Probably need to put parentheses here though, otherwise the code is gonna get angry. Not angry, just doesn't like it when you try to do weird stuff. All right, this is called Richmond something 2, right? Richmond step 2. So go ahead and name that properly. Remember, if you haven't gone in and cleaned up your catalog, you're going to have a bunch of Richmond step 2s. So you might want to pause, go fix your catalog. So that would be you go to catalog, look at your database, and you only have step 1. Good. Okay. So we check that and we're going to run, see what happens. Fingers crossed. Son of a biscuit. Oh, so annoying. Okay, somewhere in here it doesn't like this code. So what I'm going to do is I'm going to copy the code, copy, I'm going to go to Google, what's wrong with this code? What's wrong with this? And didn't match any documents. Well, you suck. Fine. T. Why is this returning zeros? Not attribute. Richmond Dem. Are you using the right tool? Yes. Problem, Richmond Dem. It's greater than 1500. It looks like a field query, not a raster. It's a raster. Richmond Dem, greater than 1500. Raster layers are in your map. Aren't they in your map? Richmond Dem, it's here. Richmond land cover is here. Okay, and Richmond slope. Oops, is Richmond slope not in here? Oh yeah, it's right there. I need to like turn them on or something. Let's try this again. What if I turn them on? Does it work? Stupid thing. No, still doesn't like it. Right. Are you using the right tool? Yes. We're using a raster calculator. Check raster alignment. No over, snap. Rasters. Check data ranges. Yes. Did that already. Land cover values might be wrong. Are those actually the correct codes? Yes. If there's no, you can control or do it this way. Okay, so I'm going to add at the end of land cover, at the end of the whole equation, I'm going to do comma, 1, comma, 0, and then another parentheses. And what this does is it controls the output. Okay, so look, I found a code answer. So I'm going to do con, parentheses, the whole thing, then comma, 1, comma, 0. So let's go back and try that. So up here, condition, not con, it's condition, right? So condition, okay, and then I'm going to move this down here, do comma 1, comma 0, parentheses, and I'm going to run it, see what happens. Fingers crossed. Usually that fixes it. Run each piece separately. Okay, so that's where I'm at now. 0. So annoying. All right, so I'm going to run each piece separately, apparently. Right click, remove, go to catalog, right click, or delete. Yes, I want that out of my stuff. So I have step 1, but I still haven't figured out how to get step 2 to work. Super fun. So I'm going to go back to geoprocessing. I'm going to try doing this one last time. Okay, so I'm going to copy this code. So I'm going to retype the whole thing. Copy. Close raster calculator. Open it back up. Paste the code back in here. Make sure everything looks right. I'm going to try it one more time, and then I'm going to do it piece by piece. Right? I think that's what it's supposed to be called. Run, Forest, run. Ugh. Still doesn't work. I know this is frustrating. Again, once I figure this out, I will, show all of you, and you can move forward. So you're just going to have to step by step. All right, so if we have to do this step by step, basically we're going to go through each of those pieces and we're going to calculate them, and then we'll switch them all together. All right, so first I'm going to do Richmond DEM is greater than 1500. Remember, there's lots of different ways to do this. It does not mean that this is a failure. We're going to call it Richmond DEM G1500. Okay, see how I did that so that I am sure what that is. Run. Now I have a 0 and 1. Cool. Now I want to get rid of that, and I'm going to do Richmond slope, right, is greater than 40, is greater than 40, and I'm going to call it Richmond slope 40, slope. I'm not going to put any spaces in there so that I don't anger GIS. Okay, Richmond slope 40, look, there it is. Okay, and now I'm going to do Richmond land cover. And land cover is double equal to 61 or 62. Cover is double equal to 62. Parentheses around it so that it knows what I want it to do. Okay, and I'm going to call this land cover Richmond LC 51, 62. Okay, this is just how I'm doing it. You can do it however you want, but make sure it's all good. Oh, would you look at that? It's land cover. The truth value is ambiguous. Okay, check the use of parentheses. Oh, so this is basically like my code is stupid. Not stupid, but I have to probably put double parentheses around the whole thing. Yeah, or in here, right? So like that, and then so your code is not stupid. I'm just being mean to myself. I don't think you're stupid. Sometimes I think I'm stupid. But if nothing else, this shows you that GIS is frustrating to all of us, not just you. Woohoo! See, it's just my code. Save that. Whew, thank goodness. Okay, so I'm going to go back to my Word document because if I put it all together, it looks like this. Okay, we're going to have to squishy these together. So it doesn't tell me how to do that in here. So how do I put these things that I just created over here all together as one? So first I'm gonna make them all look the same. So I'm gonna make them all, no color in that hot purple. So I'm gonna click on that. I'm gonna do no color and the one, that hot purple. Okay. This one, this will just help my brain visually. Okay, hot purple, no color, no color. Remember I turned some of this on. I should probably go back and turn it off. These ones that we're not supposed to be looking at, right? Yeah, slope and the put all that off. So there, look. Now we have something that looks very similar to this, right? Except that this is blue in the background and yellow in the foreground. But it's the same, see? Which is clear and purple. So now I'm gonna hit save. So look, I did it just in a different way. And that's okay. So if you end up having to do this to make it work, it's okay. And you can write in there that Dr. Horn told you that there's more than one way to use GIS and you still got the same answer. Okay, so now you have an output with a couple different things. So we need to switch together slope, basically our three rasters together. So it doesn't tell you how to do that in here, but I bet you step one was going to have to get put together with step two. So I'm going to scroll down here because let's see what it's called. So this is roads, fine, whatever. I'm going to keep scrolling and see if they told me how to do it down here. Slope, distance to trails. Holy cow, we have to do a lot of stuff still. Visibility analysis, zonal statistics, towers, input, parcels, visibility analysis. Does it not tell us? No. Parcels, 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 shoot. Okay, so I'm gonna go back up here and I don't want to raise my hand still because, I'm just feeling like I don't feel like it. And eventually I know that this video is going to tell me how to do it. So if I was a student, this is me talking to you. If I was a student, I would go like this. Go back to Google or ChatGPT, I don't care. This is a good way of using it. And you're going to write, how do I put multiple rasters together in ArcGIS Pro when I already have used raster calculator to make zeros and ones for the pieces I want. I didn't even spell it right. Binary rasters combine for suitability map. Oh, it knows what I'm doing. Okay. Concept. Yeah, I know that. Thanks. Raster calculator. Oh, so I can just add the calculators together? Oh, Boolean and more explicit. So I could just add them in raster calculator, and then I get 0 and 1. Or I could just do the 1, 1, 1s. Oh, and then if I wanted to make things differently, oh, well, that's too much. Whoa, whoa, I'm going back to this one. Why this works. 1, 1, 1, and 0. Okay, so dem, little star thing, that one, that one. Okay, cool. So I'm going back to GIS. I'm going to go back to the raster calculator. And it was the little star thing that mixes them all together. So now I'm going to put these weird names, right? Oops, I'm going to have to close the raster calculator, open it back up. Oh, now it has my fun stuff in here. So this funky one with the star, and then Richmond slope 40, and then a star, and then Richmond demigod 1500. Okay. And then I'm going to call this so that I have the right name. Richmond step 2. Richmond step 2. Okay. I think, is that right? It has all the zeros and ones. Let's see. Do I have to put any parentheses? I don't know. Let's just run it, see what happens. If it yells at me, I'll put parentheses. Son of a biscuit. Why is it doing that? No. So lame. What am I doing wrong? So something's going on here where my code must be wrong because I have all the pieces, but it doesn't want to add them together. Okay, I'm going to go back. It's usually the best method. Well, it didn't work. Oh, is it because it needs to be in parentheses? Is that, yeah, those are in parentheses. Okay, so you know what? ChatGPT, I'm gonna show you what happened, and it still didn't work. So here we go. Paste. That didn't work. That didn't work. And yes, I know that it should. Mads when typing poorly. You're overwriting your own raster. ArcGIS does not like to overwrite. Blah, blah. Oh. Okay. ArcGIS is a pain in the butt. Okay, remove, catalog, remove, delete. I'm just gonna call it something totally different too, okay? Because I don't want to do this like 10 more freaking times. Step 2B. Let's see if that works. Run. I'm gonna take a deep breath now, and I think I'm gonna take a break because I'm a little frustrated. So I'm gonna stop sharing my screen, and I'm gonna stop recording, and I'll be back. And hopefully you will too. Okay, folks, I'm back. I went to get a cup of coffee. I took a break, and now I'm back. Let's see. Let's share my screen. Okay, so here I am back in GIS. I have triple checked that each one of these three raster files does in fact have 0 and 1s, and then here's my initial step 1. So what I'm going to do is go back up here, and I'm going to reread this really carefully. Okay, now you've identified off limits in step 1. Now we're going to combine these three horrible raster files that keep making me want to stab myself in the eye. Use what you've learned to create a query in the raster calculator that identifies all the pixels that meet any of the criteria specified in the preceding paragraph that meets any of them. Okay. Uh-oh, I think I know what I did. Name your output. Step 2, hint, there are no and operators. Only or. Okay, yep. Raster calculator is represented by the vertical line symbol known as the pipe. Yeah, thanks. Make sure that each piece of the query is surrounded by parentheses like you see in the syntax above. Double hint, the land criteria needs to have double parentheses similar to this. Okay, and then we want it to be like this. All right, so I've been doing and it's not supposed to have and. So let's go back. Richmond, excuse me, raster calculator. I'm going to go ahead and do little pieces that I've made. I already did all that work. It's this easy. Well, I'm going to call it Richmond step 2. All right. Is that all it was? Is I needed to do or instead of and up here? Wow. All right. So isn't that fun? Here's a great example of why you read things in detail. Phew, that's so fun. Okay, so now we can open up the attribute table of step 2 and examine the stuff. Recall that the count attribute indicates how many cells in the raster have that particular value. You can multiply the number of cells by the cell size, okay, and you can look it up and figure out the value. All right, so I'm gonna go ahead and minimize these little ones that I made because, you know, that's just extra stuff. I'm gonna open up the attribute table of Richmond step 2, and look, there's that many zeros and that many ones. I can always open up the properties because my brain is tired, and I go to, let's see, is it source? Yep, when I go to raster information, and it tells me cell size is 26.5 by 26.5. Okay, is that right? Probably. What are my statistics? Okay, and tells you the extent of your raster. Okay, cool. So now I can go back to my quiz, and what is the total area identified as off limits? So off limits are ones, right? Okay, just as a heads up. Go ahead and answer that. So now we're going to identify land that's suitable for development. Now that you've determined locations suitable for the subdivision development, it's time to look for areas in town that meet the minimum suitability requirements for a new cabin. You're interested in 2 specific criteria: distance from roads and distance from trails. So you want to site a cabin that's far from Interstate 89 and Route 2, which is part of Richmond roads, but near one of the town trails. Okay. So to do this, you need to compute a distance surface for each of these features. A distance surface calculates the distance from a pixel, which is in a raster dataset, to the nearest feature in a vector dataset. Okay, that's cool. So we're going to use a new tool, kind of. Euclidean distance tool, and ignore the warning. Sounds fun. All right, so I'm going to close that. I'm going to save. Okay, I'm going to go to Euclidean distance, type that in, Euclidean distance. Look at that, pops up really fast. That's nice. Okay, I think it walks me through what I want to do. All right, so we are going to input is the feature source, which is the roads, and the output, we're going to call it distance to roads. Notice that the output cell size parameter matches the cell size you specified when you established your environment settings. Okay, so the distance to roads raster layer you create should look similar to the figure below. So if it doesn't, it means that our environment settings are messed up. So we're going to do Richmond roads, input Richmond roads, output distance to raster is, what did they want us to call it? Sorry, I'm tired now. Distance to roads, distance to roads with no spaces. Okay. Output cell size. Okay. Um, then we're going to make some symbology changes rather. All right, so let's go ahead and run this and see what happens. Look at that, it worked. Thank goodness. Let's hit save. Does it look kind of like the map? Green in the middle, orange. Yep. Okay, cool. Awesome. Don't have to do anything else with that. Thank goodness. Okay, now you can answer this question. What's the maximum distance to road within the 2-kilometer buffer? Pick the closest answer. Okay, so let's open this. Oh, you don't have to. Look, the values are right here. Okay. Next, let's create a cost-weighted distance surface to trails. So the grid cells with steep slopes contribute more cost to the distance value with the grid cells with gentler slopes. So basically, the cost is a way to, because it's a raster, we can't just measure things. So we have to use a different kinds of tool. So we use this cost distance tool to create, basically you're coding a value for each little pixel. Okay, that's what you're doing. And that's what this tool does for you. Similar to what we've talked about when you're doing a search for something and what's more important to you or less important. Okay. So we're going to go ahead and add, we're going to go to the cost distance tool. So up here, cost distance tool, spatial analysis. Our input raster is going to be, should be Richmond Trails. Oh, yeah. Input source, yeah, is Richmond Trails. And the input cost is going to be Richmond Slope because that's what we care about. So Richmond Trails, and then we're going to use Richmond Slope because, and remember, we're not using the little baby ones that we made, right? We're going to use the big regular one. Okay. And so if that is confusing, you can just get rid of those. You don't have to save them anymore. The output, we're going to call it distance to trails. So we're naming this distance to trails. Distance to no spaces. Make sure there are no spaces. That looks like a space. It's not. Okay. Does it want us to set a new maximum distance? No. Go ahead and run it. Cool. That looks fun. I'm going to click save just in case the GIS evilness, we know we're talking about, the gremlin comes out. Okay, so now you have a raster data set showing the distance to the nearest trail. Again, you're going to get a warning down here. Just ignore it. It's fine. Don't worry about it. Weighted by the steepness of the slope between a grid cell and the nearest point on the trail. So basically between a little pixel and the point on the trail, whatever that slope is, okay? Therefore, a grid cell that is 100 meters from the nearest trail, but is only accessible via a steep slope, has a much higher cost weighted value than if it's 100 meters from the trail, but it's flat. So think about, like, are you, it'd be much harder for your grandparent to walk up a super steep slope. So instead of it being called harder or difficult, the cost is higher. Okay, that's the verbiage here. So now what's the maximum value of our distance to trails? You can just pick the closest answer. It's not exact. All right. Finally, to complete the analysis, oh, thank goodness, you are going to identify locations suitable for a cabin, which is Richmond step 2 equals 0. Thank goodness we did that, right? And identify those locations when accounting for the slope. So any distance to trail that is less than 1,000 meters and is greater than 2,000 meters from a road. So those are our 3 raster images. So, oh, fun. We get to go back and use the raster calculator again. Okay, so what is it? Step 2, distance to trails and distance to roads. Okay, raster calculator, Richmond step 2. We want Richmond step 2 equals 0. 0. And these are all and, so we're going to do the whole parentheses. This is for sure and, not or, so we don't have to go through that whole debacle again. And distance to roads, it's going to be greater than something, right? Greater than, distance to roads is greater than 2,000 meters, so greater than 2,000, assuming that that's what it is in there, is in meters. And distance to trails, which is what we just made, so this should be in here. Distance, did I not make that? Uh-oh. Oh, cost. Oh, it's because I didn't change the name. Great. Bad. That's annoying. I might go back and clean that up in a second. Shoot, I should just do that. Dang it. Okay. All right, what tool was that? Cost distance, right? Cost distance. Yeah, so remove, go to my catalog, get rid of this cost distance thing. Yes. Yes, I know this is really doesn't seem like it's that important, but it is. Okay. So distance to trails. What was I supposed to do? So open cost distance, input is trails, and the cost is slope. That's right. Okay, input is trails, the cost is Richmond slope, and we need to call this distance to trails. Okay. Listen, if you don't want to go back and do that, it's fine, but you just need to remember that that's what that is. Because when you go to look at things, you may or may not remember, all right? And so there's your answer again for that previous question. I go down here. My last thing. Okay, so now I'm going to go back to raster calculator. I'm going to do Richmond step 2. Is equal to 1 or 0. Richmond step 2 is equal to 0. That's all the places that they're allowed to build. Remember, because our ones were the places that we don't want them to build. Okay. And let's see. And distance to trails is less than 1,000 meters. So distance to trails is less than 1,000. Parentheses so that the code is read properly. And distance to road is greater than 2,000, I think, right? I think that's right. Distance to road. Oh, is greater than 2,000. Okay, I'm just going to double check. Less than 1,000, greater than 2,000, and we're going to call it Richmond cabin sites. Oh, fun. Richmond cabin sites. Okay, crush fingers so we get this done correctly. Woohoo! How fun. So you can see some of the other images in the background. That's why there's some color here. Okay, Richmond cabin sites. Cool. Awesome. So I'm going to save that so I don't mess it up. All right. What is the total area of suitable cabin sites identified in the analysis? So, oh yeah, go ahead and make zeros invisible and ones super bright. Okay, got 0 color, ones to be super bright. That because I'm feeling sassy. You can pick whatever color you want, doesn't matter. Okay, no judgment on any of that stuff. I can turn off Richmond step 1. So I just have this here. Go ahead and save it. I can go ahead and open up my cabin sites attribute table. And this tells you how many cells there are. Okay, so then you have to pick how many meters there are. Remember, you multiply the number of cells by the size. Okay, you find that under properties. Woo, okay, now we're on to part 5. I think I'm going to pause and take a break for a second. It's lunchtime for me, and let's see how many pages we have left. A lot. So maybe I'll make a part 3. Okay, I'm going to stop sharing my screen, and I will make a part 3 for you. I promise, don't worry.